On December 27, 2024, astronomers discovered a new asteroid. This asteroid, designated 2024 YR4, has caused a stir in the scientific community and beyond. The reason for this concern? A small but significant chance that YR4 could collide with Earth. Calculations show a 1.3% probability of impact on December 22, 2032. While the odds of a collision are low, the potential consequences are substantial enough to warrant attention. Asteroid 2024 YR4 is estimated to be between 40 and 90 meters in diameter. To put that in perspective, that's roughly the size of a football field. An impact from an object this size would release an enormous amount of energy equivalent to a powerful nuclear bomb. The devastation would be significant, particularly if YR4 were to strike a populated area. However, it is important to remember that the Earth's surface is mostly water. It is far more likely that YR4, if it were to hit Earth, would impact one of our planet's vast oceans. Despite the potential danger, it is crucial to approach this situation with a level head. The vast majority of asteroids that enter Earth's atmosphere burn up completely before reaching the surface. These fiery events, known as meteors or shooting stars, are a common and harmless occurrence. Even if YR4 were to survive atmospheric entry, the likelihood of it striking a populated area is slim. The Earth is a large target and much of its surface is uninhabited. While the possibility of an impact cannot be ruled out entirely, it is essential to keep the risk in perspective. Scientists are continuously monitoring YR4's trajectory, and the probability of impact is likely to change as more data is collected. The international community is also prepared to take action if necessary. Various options exist for deflecting or destroying an asteroid on a collision course with Earth, and these will be explored in greater detail in the following sections. To assess the potential threat posed by near-Earth objects like asteroids and comets, scientists use a tool called the Torino scale. This scale, ranging from 0 to 10, provides a simple way to communicate the likelihood and potential consequences of an impact. A rating of 0 indicates an effectively zero chance of collision, or an object so small that it would pose no hazard. At the other end of the scale, a 10 signifies a certain collision with global consequences. Asteroid 2024 YR4 currently holds a rating of 3 on the Torino scale. This places it in the close encounter category, meaning that YR4 warrants careful monitoring by astronomers. A rating of 3 also suggests that the probability of impact is low but not insignificant, requiring further attention from the scientific community. It is important to note that a Torino scale rating is not static. As more observations are made and the asteroid's trajectory is refined, its rating can either increase or, more likely in this case, decrease. To understand the significance of YR4's rating, it's helpful to compare it to other recent asteroid events. In 2004, an asteroid named Apophis caused a stir when initial calculations suggested a significant chance of impact in 2029. Apophis was briefly assigned a Torino scale rating of 4, the highest rating ever given to an asteroid. However, as more observations were gathered, Apophis's orbit was recalculated and the risk of impact was downgraded. Apophis is now known to pose no threat to Earth for at least the next century. The case of Apophis highlights the importance of continued observation and refinement of asteroid trajectories. Initial calculations are often based on limited data and can change significantly as more information becomes available. In the case of YR4, the current Torino scale rating of 3 serves as a reminder to remain vigilant and continue monitoring this celestial object. The scientific community is taking all necessary precautions to track YR4 and will continue to update the public as the situation evolves. The discovery of asteroid 2024 YR4 and its potential for Earth impact, while concerning, is not without precedent. The history of our planet is punctuated by encounters with celestial objects, some leaving behind dramatic scars on the Earth's surface. One such event, the Chicxulub impact roughly 66 million years ago, is believed to have played a significant role in the extinction of the dinosaurs. While such catastrophic impacts are exceedingly rare, they serve as a stark reminder of the potential consequences of asteroid collisions. In more recent times, the asteroid Apophis, mentioned earlier, provided a valuable lesson in asteroid monitoring and risk assessment. Apophis, discovered in 2004, initially caused widespread concern due to its size and projected trajectory. Early calculations suggested a 2.7% chance of impact with Earth in 2029, a probability that, while low, was significant enough to warrant serious attention. The asteroid's potential for destruction, estimated to be equivalent to thousands of Hiroshima bombs, only heightened the anxiety surrounding its discovery. However, the story of Apophis also highlights the importance of continuous observation and the iterative nature of scientific discovery. As astronomers around the world turned their telescopes towards Apophis, gathering more data on its orbit and composition, the picture became clearer. The initial calculations, based on limited observations, were gradually refined. Thankfully, with each refinement, the projected risk of impact diminished. Today, thanks to the diligent work of the global astronomical community, we know that Apophis poses no threat to Earth for at least the next century. The experience with Apophis, while initially alarming, underscores the critical importance of maintaining robust asteroid detection and monitoring programs. Early detection is key to mitigating potential threats. The more time we have to study an asteroid's trajectory and composition, the better equipped we are to develop effective strategies for deflecting or disrupting a potential impact. The potential threat posed by Asteroid 2024 YR4 has triggered a coordinated response from international organizations tasked with planetary defense. The International Asteroid Warning Network, or IADUN, established by the United Nations, acts as a global clearinghouse for information related to near-Earth objects. IADUN facilitates communication and collaboration between nations, ensuring that all relevant data on potentially hazardous asteroids is shared promptly and effectively. In addition to IADUN, the Space Mission Planning Advisory Group, or SEMPAG, plays a crucial role in coordinating international efforts to mitigate asteroid threats. SEMPAG brings together experts from various space agencies to develop and assess potential deflection strategies. These strategies range from relatively simple techniques like using a spacecraft's gravity to nudge the asteroid off course, to more complex options such as detonating a nuclear device near the asteroid to alter its trajectory. The choice of deflection strategy depends on several factors, including the asteroid's size, composition, and remaining time until potential impact. In the case of YR4, given its relatively small size and the decades remaining until the potential impact date, less drastic measures such as the gravity tractor method or a kinetic impactor are more likely to be considered. The gravity tractor method involves using a spacecraft's gravitational pull to gradually alter the asteroid's trajectory over an extended period. The kinetic impactor, as demonstrated by NASA's recent DART mission, involves crashing a spacecraft into the asteroid at high speed to slightly alter its path. While the threat posed by Asteroid 2024 YR4 is a cause for concern and vigilance, it is essential to remember that the international community is actively monitoring the situation and is prepared to act if necessary. The lessons learned from past asteroid encounters, like that of Apophis, have strengthened our ability to detect, track, and potentially deflect these celestial wanderers. Continued investment in research, technology, and international collaboration will be crucial in safeguarding our planet from future asteroid threats.